Hello, everyone. My name is Gamanji, and I am one of the cloud platform engineers for American Express. I joined American Express around 5 months ago, and I am part of the team that aims to transform the current platform by embracing the cloud native principles and making the best use of the open source tools. As well, quite recently, I've been elected as one of the TOC, or Technical Oversight Committee member for the CNCF. Alongside 10 other champions within the open source community, I will be responsible to steer and maintain the technical vision for the CNCF landscape. Pretty much, we are the committee that enables and leverages projects to join the open source. Today, however, I would like to talk about the building blocks of DX, and more specifically about the evolution from CLI to GitOps. And to do so, I would like to introduce the cluster CLI, known as kubectl, and its support for declarative and imperative approaches. Now, these are quite handy because this is going to transition towards the DX enhancement section, which is going to focus on how can we extend kubectl commands by using plugins, or how can we wrap them by provisioning different dashboards and portals. And lastly, I would like to conclude by providing an overview of some of the techniques that will automate some of the commands provisioned by kubectl. And in this particular section, I'm going to focus on mechanisms such as ClickOps, GitOps, and even SheetOps. Wait till the end, is going to be amazing. Now, before I move forward with the topic, I would like to introduce the ecosystem that allowed this evolution from the CLI to GitOps. If you look 6 years ago, the container orchestrator framework space was very heavily diversified. We had tools such as Docker Swarm, Apache Mesos, Kubernetes, and all of them provided a viable solution to run containers at scale. However, in the last years, Kubernetes took the lead in defining the principles for containerized workloads. Nowadays, Kubernetes is known for its portability and adaptability, but more specifically for its approach towards declarative configuration and automation. And this prompted for a huge user base to be built around Kubernetes. Based on the CNCF survey in 2019, more than 58% of the companies are using Kubernetes in production. The other 42% of the surveyed companies are using Kubernetes, actually prototyping Kubernetes as a viable solution to move forward. Another milestone I would like to mention here is that more than 2,000 companies are using Kubernetes in an enterprise setup. Now, this really showcases the wide adoption rate and the maturity of this tool. When we transition towards the development community, more than 2,000 engineers are actively collaborating towards feature build-out and bug fixing. And when we're looking into the end user community, more than 23,000 attendees were registered at the KubeCons around the world. Now, these are going to be KubeCons in Europe, China, and North America. And this has been extremely beneficial for Kubernetes because over time, multiple tools were built around it to extend its functionalities. And this created what today we know as the cloud native landscape, which is organized by the CNCF. Now, if you look into all of this tooling, some of them are going to provision similar capabilities, such as service mesh, for example, or networking runtime. And a more diverse tooling means that we're going to have a more diversified user base as well. We're going to have different engineers with different exposure to Kubernetes, having this need to interact with this tool. And from all of these personas, we can identify 3 main groups: the application developers, application operators, and infrastructure operators. The application developers are going to be the engineers which will focus on the business logic, and they don't necessarily need to interact with Kubernetes. However, they will need to build the application in a way to be consumed in a containerized context. For example, some of the best practices are to create the readiness and liveness probes endpoints, or to build a Docker image for your application, or to make sure your application restarts properly when the container itself is going to be restarted. The second persona we're going to identify are the application operators, and these are going to be the engineers which actually deploy the application to the cluster. They will interact quite vividly with Kubernetes resources. Usually, the application developers and operators is an overlapped role. However, it's not always the case. Hence the segregation of these 2 personas at the moment. And the last group of users we need to think about when you're talking about Kubernetes are the infrastructure operators. Now, these are the engineers who have the full context of how an application can be pushed through the cluster and updated, but more importantly, they'll have an understanding of the entire lifecycle management of the cluster itself. They'll have an understanding of the core components as well, how to create or manage a cluster altogether. But more importantly, we really need one set of tooling to allow all of these personas to connect to the cluster in a unified manner. And this is where the cluster CLI comes about. By default, Kubernetes has a command line tool known as kubectl, which will allow the interaction and management of Kubernetes objects. kubectl pretty much is the bridge between the local terminal for any users and a cluster running, for example, locally or remotely in a data center or public cloud. To actually make sure that we can connect to those clusters, the kubeconfig file is necessary. And this kubeconfig file is going to have all the metadata required to access those clusters, such as the API endpoints and any authentication metadata we require, such as CA certs or tokens. Usually this file is going to be stored in the .kube folder at the root directory. However, it can be consumed as a flag for the kubectl command. Or alternatively, it can be consumed as an environmental variable on the system. When we refer to kubectl, we refer to SIG CLI, which currently resides under the Kubernetes community umbrella. kubectl offers more than 40 operations, and these are going to be actions we can perform on actual Kubernetes resources, such as create or get, update, and many more. And these operations are actually associated with more than 70 flags, which allows us to have this really tailored and customized experience when we want to get something from the cluster or want to create something for the cluster. But more importantly, kubectl is known for its support for declarative and imperative management techniques. And I would like to introduce these two in slight more detail. The imperative approach is when a user actually types kubectl commands and they will directly interact with the live objects in the cluster. So if they do a kubectl delete, that object is going to be removed straight away. Or if they do kubectl create, for example, that object is actually going to be created. Now, the advantage of this approach is the fact that it allows for one common deploys, and it's very easy to assimilate. Now, when I mean the one common deploys, for example, as an engineer, if you have a Docker version of your application, the only thing you really need to do is just do a kubectl create, tag your image, and your application is going to be in the cluster. As easy as that. However, on the downside of this approach, we don't really have the source for our configuration, which translates that we don't really have templating that we can reuse in the future we can share with the other team members. As well, it's a good technique. Actually, because of that, it's a good technique to be used for development stages only. The declarative approach is slightly different, and this is because it operates on files stored locally. And this is represented by a full declaration of your YAML files. A good thing about the declarative approach is the fact that it has directory level operations. For example, when you create an application, it's not just going to be a deployment. It's going to be a deployment associated with a service. Sometimes they will require to read configuration through a config map or to access a secret. If they want to scale horizontally, there's an HBA object needed to be configured. And these are already more than 5 resources that needed to be created. With a declarative approach, we'll be able to apply any changes to all of these resources with one command. However, on the downsides of this approach, it actually presents quite a high learning curve because a further understanding is required of the nested configuration for the YAML manifests. And this introduces a slight more complexity when it comes to troubleshooting and debugging. Now we can see that kubectl is a great platform to explore the cluster assets. However, it is generally and wrongly assumed that everyone interacting with the cluster will be fluent in operating with kubectl. A clear path was discerned for the community to concentrate on enriching and enhancing the cluster DX to make it accessible to engineers of all levels. And here I mean our application operators and application developers. Now, when we think about any DX enhancement, there are 4 main principles we can take into account. There's going to be simplicity, optimization, transparency, and durability. With the simplicity principle, if we introduce any new commands to be consumed or any new interfaces, it really needs to concentrate on being simply to consume. So it's going to be very straightforward for our engineers to interact with this tool. The optimization concentrates on actually identifying patterns that we would be able to automate. For example, if your engineers are all the time looking to get the CPU and memory for your pods, instead of them grabbing the YAML and actually looking for the manifest, you'd be able to write one custom command. So it's about optimization. The third principle is all about transparency, and this is something which should be true at all times. If you allow your engineers to deploy something into your platform, they should be always aware what the application is and how they can connect to it. But more importantly, they really need to be aware how to troubleshoot and debug the application, because this is going to be a huge unblocker for them. And the fourth principle we're going to refer to is durability. Now, if we introduce any changes to the way your engineers are interacting with Kubernetes, it's really important to think about these changes for the long term. And this is going to imply that it should be simple to consume and it should optimize multiple operations. But more importantly, thinking long term will allow us to build on top of the current strategy, for example, that you're implementing. And when we refer to kubectl, there are two areas of DX enhancement we can identify. The first one are the extensions, referred to as kubectl plugins. And the second one are the wrappers, which are translated through web and terminal UIs. Let's focus a bit more into both of these categories. Now, when we refer to kubectl extensions, these are plugins. And this is a methodology to really write custom commands to be consumed through kubectl. The good thing about this particular mechanism is the fact that the plugins can be written in any language, because underneath is just an executable or a binary. And as long as it complies with some of the requirements, such as the location or the naming of the file, it's going to be identified by kubectl straight away. But the most important thing we can withdraw from this is that it really allows for us to have this custom and tailored experience where interacting with the cluster. And this allows us to introduce some of the core principles, such as we really can optimize, we really can customize some of the commands, and we really can make it more simple for our engineers to get the kubectl resources. And at this stage, let's look how a kubectl plugin could be written. In this particular case, I have a shell script, which is going to issue an echo command. Pretty straightforward. However, I would like to draw your attention towards the path of this binary. As you can see, it's already in one of my binary folders, which is already defined in my path environmental variable. The other thing I would like for you to get your attention towards is the naming of the file, so kubectl greetings. It is very important for any plugin to be prefixed by kubectl, and then any words which are following kubectl are going to be the actual command. I don't really need to do any installs, to be honest. As long as the file is going to be in the right location, one of the binary folders, then the plugin is going to be identified and is going to be listed. So in this particular case, I can see our kubectl greetings plugin and any other plugins have been installed for Crew. And to issue our command, so to actually make sure that it works, the only thing I need to do is kubectl greetings. And this will go to our binary, it will execute it, and output hello Cam Cloud Native. As easy as that. However, over time, there were patterns discovered not just within one companies, but across the community when it comes to the kubectl plugins. And there was a necessity to index and curate all of them by using one centralized service. And this currently is provisioned by Crew. You can think about Crew as a service discovery for plugins. And currently it offers more than 40 custom add-ons that can be installed with just one command. One of the cool features for Crew is the fact that it has its own plugin version manager, which means that you'll be able to update your plugin moving forward or identify new versions and so forth. And I would like to showcase at the moment some of the most widely used plugins or some of the most widely downloaded plugins for Crew. And the first one, as you can see here, is actual Crew. We have a slight inception here because Crew is a plugin to install our plugins. So by default, it's going to be one of the most widely used tools. And currently it reaches almost 100K downloads. The other most popular plugin is going to be the Ingress Nginx. And this is going to allow for the inspection of the Nginx controller, Ingress controller. The third one is going to be tail, and I think this is quite common and quite widely used. And tails allows the streaming of the logs from a collection of pods. So instead of doing get logs from one pod, you'd be able to do so at the deployment level, for example. Score is another tool which allows the static analysis of your Kubernetes manifests, while the YDC login is another plugin which allows the connection to any OpenID Connect provider. Now, if you'd like to distribute our greetings plugin, because we had it locally at the moment, if you'd like to distribute it widely with the community, the first step is actually writing a CRD or customer source definition. And this CRD, in this particular case, we have a trimmed output. We're going to look at the full manifest during the demo. But in this particular case, we can identify two areas for configuration. The first one is going to be informative, and the second one is actually going to be steps to install the binary. So in the informative part, we can see parameters such as the version of the plugin, homepage. We're going to have a short and a long description, which will allow us to have this help message when the users will interact with the plugin. And the second area is going to be the platforms. And here we can specify on which operating systems our binary should be executed. So for example, if you've written something to work on Windows machines, you'll be able to specify that. Otherwise, if it's intended to run on Linux machines, again, you'll be able to select that operating system. The second step is going to be to actually point it to a zipped file of the entire release, and we're going to provision it with a checksum to make sure that we have the integrity of our files. And the last thing we're actually going to specify is going to be the actual executable binary, which needs to be invoked with kubectl. And I think this is going to be a very good segue to do the demo. Hopefully, my screen can be seen. So what we're going to demonstrate today is how can we do a local install of our greetings plugin for Crew. So currently, if I do a list of all the plugins I have available, I'll be able to see I have Score and Tree and Crew, but I don't have the greetings plugin. And just to confirm, I'm just going to do a list of plugins which were installed via Crew. And again, you can see the same top, actually, plugins, but with a different version. At this stage, let's look at our plugin CRD. So as mentioned, we have two main areas. The descriptive one, in which we have the version. My descriptions here are quite straightforward. It's just a greetings message, but you can really go above and beyond and make it really useful to have this, especially if you have multiple commands for your plugin. And the second one is the install part. And in this particular case, we specify that we'd like to install or execute our binary on Darwin and Linux operating systems. As mentioned before, we're going to provision it with our zip file. What I would like to draw your attention towards is that our plugin version does not necessarily need to comply with the version that Crew actually uses. And this is, again, a separate mechanism. They can obviously overlap or they cannot. It's a mechanism for you to choose and move forward. And once we have our binary, we'll perform an extract operation. And in this particular case, we extract everything. However, you can really focus on just specific parts of your repository. And the last thing we're going to do is point to our greetings.sh. And just to confirm, I'm going to look at our greetings.sh. It's just a binary file with an echo command. Cool. At this stage, let's install our plugin for Crew. For that, I'm going to do kubectl crew install, and I'm going to point it to our manifest, or CRD, which is plugin.yaml. Oh, cool. I forgot to unset the corporate proxy, so I'm going to do that very quickly. Oh. And let's try again. Cool. Now we have our plugin being installed. It'll prompt with all our greetings message and so forth. And to just confirm that, I'm going to do a kubectl plugin list. I'll be able to see that we have our greetings plugin now. If I do a Crew list, we see our new plugin as well. And the final representation that this actually worked is to actually invoke the command. So I'm going to do a kubectl greetings, and it will actually issue our echo command. As easy as that. Going back to the slides, cool. Now, before I move forward with the topic, I would like to leave you a few takeaways about kubectl plugins. Now, the first thing to remember about kubectl, it really allows for a tailored experience to be built for our engineers. And this is a very powerful mechanism because it focuses on the simplicity of consuming these commands. Usually kubectl is going to be available on the machines of our engineers. We can write extra commands for it. And it allows for optimization. We can really abstract some of the most bothersome, for example, commands for our engineers. The other thing I'd like to mention about kubectl is the fact that it's a quite widespread practice to use kubectl plugins and aliases. And this is something which we actually do in American Express, and I'm going to showcase that in the next slide. And whilst we cannot currently overwrite any of the existing verbs, for example, we cannot override the get command, it's always going to have the same behavior, we still have a bunch or plenty of plugins which are just install away. And to actually showcase how do we use the kubectl plugins kind of formula with the aliases, I would like to introduce OneCLI, which is a tool we developed in American Express. Now, OneCLI is a developer productivity tool, and it actually allows to integrate with different services that we offer for our engineers. It's not just the infrastructure service. They'll be able to connect to their CI, for example. Now, one important thing about OneCLI is the fact that you can think about this as an AWS services for applications or functions we offer within One Amex or American Express. And currently for one tool, we'll be able to connect to all of those services. So in this particular case, one is actually our tool. We're going to set up our service. So it's going to be infra. We're going to perform any operations on our infra context. And then it's going to follow by the operation itself, which is going to be OpenShift login. And then we'll be able to specify the environment as well. And in this particular case, we use E1, which is just an acronym for our development cluster. Now, so far we can see that we can extend the way we can interact with kubectl and Kubernetes. The next step is to actually see if we can simplify this for our application developers. Again, it is wrongly assumed that everyone is going to be fluent in kubectl. It's not always the case. And for application developers, a very useful methodology to interact with the cluster is going to be through web and terminal UIs. And this is why we require an operational view of the cluster state to actually remove the complexity of how to get or interact with some of the resources. With the kubectl wrappers, it's really represented as a point of presence. In any team, usually, you're not going to just have one cluster. You're going to have at least one cluster per environment. And this is going to be multiplied by the amount of regions you have, for example, and how many areas of the globe you distribute your cluster. So it can get quite hefty. You can get, for example, to more than like 10 clusters or even 100 clusters. Depends on the infrastructure. The second point about the kubectl wrappers is the fact that it's developer first. Again, they do not assume that the users have a knowledge about Kubernetes. However, they will be able to explore the cluster assets. It is important to say here that in the dashboard, we're going to have a finite amount of actions that we can perform. And it's a really good way to explore what's available for Kubernetes platform. And looking into the tools lately available in the community, the kubectl wrappers or the dashboards and portals, they provide a coverage of basic operations. Most of these dashboards are going to be read-only. However, they provide supports for operations such as delete, scale, sometimes port forwarding as well. When we're looking into the ecosystem at the moment, we have plenty of tools provisioning these capabilities, from which, as mentioned before in the previous talk, we have Octant, which is developed by VMware. And Octant is a very good tool to provide for our actual application developers. And I'm going to showcase a demo of that later on. A different tool which has gained quite a lot of momentum is K8s, and this is represented through a terminal UI, which has a wrapper around the entire kubectl suite of commands. And it's quite a handy tool because instead of actually typing the full commands, you'll be able to navigate through resources by using your arrow keys, for example. Lens is a different tool, which is a Kubernetes IDE and can be installed on any operating system as a standalone application. And Spectate is an extra tool that concentrates actually more on exploring the networking components of an application. It will usually showcase the deployment and its service and ingress, which is associated with that deployment. Spectate actually hasn't been for a lot of active commits currently. So if you think it's a great tool, please go talk with the maintainers and contribute to the project. And to actually showcase how can we truly enable the exploration of Kubernetes for UI, I would like to showcase Octant at the moment. So one of the first points we've mentioned is the fact that we have one point of presence for all our clusters. So currently I have a bunch of clusters available. I'm just gonna stick with my kind demo, but more importantly, we're gonna have an overview of all the available namespaces. Thinking from an engineer point of view, this is extremely helpful for them to identify where they are positioned in the cluster. A cool thing about Octant as well is the fact that they provide a interlinking between the resources in the cluster. So currently, if I look at my Argo CD application controller pod, so this is just my pod, just gonna go through. It's actually linking it to a replica set in the deployment, a service account, and a secret, and for example, services. So if you have any volumes, for example, or any configuration modes that you consume for that, you'll be able to see all of them interlinked in one view. And a cool feature I would like to showcase as well, if you go to our workloads and our pods, the port forwarding feature. Usually, if you have to do it for kubectl command, it's quite a scary command, right? So you have to choose the port, you have to get the right port to for the external and the internal port. With Octant, you'll be able to do that with just one click. You start the port forwarding, you navigate there, and you actually see your application straight up and running. And it's a very good experience for the developers to actually test their application with minimal hassle. And this dashboard itself is actually, it provides lots of functionalities. I'm not going to go into details for all of them, but it actually provides an overview for the admins of the cluster. For example, I'll be able to inspect my nodes. I'll be able to see the underlying operating system or the version of Kubernetes we're running, and many more. But more importantly, with any tool nowadays, it has the choice of the light and dark color schemes. So that's already a solve for me at least, quite handy. I'm not going to go into too many details to showcase the tool. You can obviously download it and interact with it by yourself and trial it. Now, so far we can see that we can extend and visualize the user journey throughout the cluster. However, if all of these commands have been performed usually manually, you actually have to type the kubectl commands manually to create or interact with an application. The same goes with the portal and UI, so I had to click for all of the menus to visualize it. If you're thinking about a deployment, you really need to think about automation. This is exactly where we actually require templating as well. When you think about automation, is usually one set of configuration that we'll be able to reuse across many clusters, but at the same time have a very balanced configuration overhead. And this currently is provisioned by configuration managers such as Helm and Customize. These tools actually provide fundamentally different functionalities. However, they overlap when it comes to the templating of the resources. Currently, Helm is a template-driven mechanism that will work with the value injections. So we're going to have the full declaration of our manifest. However, we'll be able to inject any values, and that's how we customize it. A controversial kind of idea here, but I see Helm tilting towards the imperative approach more. And this is because imagine the context where you have a Helm chart, like an umbrella Helm chart with multiple charts plugging into it. You're going to have a bunch of variables and defaults. And usually you're not going to set up all of them, just a subset of them actually going to be configured. And because of that, it tilts slightly towards the imperative approach. And the good thing about Helm, it actually comes with a collection of upstream charts that we'll be able to use to install any new applications with just one command away. And customize is completely different in this regard. It actually uses a template-free mechanism. So because of that, you're going to have the full declaration or manifestation of our YAML. And that's why it's actually using a declarative approach. However, the way customize works, it's actually use the deep merges. So it will be able to add or replace any parameters over there. When it comes to actually automate and customize the configuration for multiple clusters, with Helm, we'll be able to do that through multiple values files, while with Customize, we'll be able to do that with a base and multiple overlays. And for example, if you'd like to template a deployment and a service, usually this is going to be a values file. We can specify the name of our application, which is going to be Asimov, amount of replicas, the image itself, and then we obviously can enable our service as well. Whilst with Customize, the approach is slightly different. We will actually have the full representation of deployment and service at YAML. So this is going to be a declarative representation. We can replace our image. So from Asimov, we will point it to an image.registry/Asimov and a tagged image. And if you'd like, for example, to change the amount of replicas, we'll have to use a JSON patch, which will perform the replace operation. And once we actually have templating, we can really think about mechanisms of deployment. And some of the most popular and widely used nowadays are techniques such as ClickOps, GitOps, and SheetOps. And I would like to introduce them. And at the end, I'm actually going to showcase a demo of SheetOps. So look forward to that. Now, when we're talking about the ClickOps approach, the application deployment is represented by a collection of clicks through a set of menus. Now, this is something which is provisioned by the cloud providers and services. And whilst it provides a very powerful DX, as an engineer, you don't really need to be aware of all configurations that's available. You just have the right amount of configuration surface. It's very important to keep this at a good balance. So how can we ensure a good and balanced abstraction level? However, with the ClickOps technique, some of the questions are, how do we do rollback? So for example, if you would like to deploy the previous version of the application, how you'll be able to do that? Is it going to be again, a myriad of clicks through the settings? Do you actually write this code? And this implementation itself, I think, differs from a use case to use case. When we refer to the GitOps approach, this is currently represented by Git repositories as the source of truth of how we would like to describe our application in a cluster. And currently, GitOps is a powerful mechanism because it's PR rollout. That means that the delta between the actual engineer's local terminal or desktop and the cluster is just one PR away. We can really push these changes with minimal effort. And because of that, we have automatic reconciliation. The GitOps model works on a pull model, which means it's going to look for or watch a particular Git repository. And if it sees any changes, it will be able to identify them and apply them to the cluster. But more importantly, with GitOps, we really have a version state of our cluster. We really have data points, historical data points as well, where we'd be able to go a few commits back or forward, and really be able to manage our cluster historical pipeline that way. When you're looking into the ecosystem at the moment, GitOps currently is provisioned by tools such as Flux and Argo. Flux has been developed by Weaveworks and is currently a sandbox CNCF project, while Argo has transitioned to CNCF incubation level quite recently as well. It is worth to mention that currently at American Express, we are prototyping Argo CD to create or push our manifest to Kubernetes. And the last but not least, I would like to introduce the SheetOps mechanism. And if you're asking why, the question, well, the answer is going to be because why not? SheetOps is a functionality which aims to control the Kubernetes state using Google Spreadsheets. And their mission is to actually replace YAML with spreadsheets. If you're one of the engineers who dislikes YAML and you have Excel close to your heart, I think this is your moment to shine. They actually currently are looking for contributors. It's quite a new project. They have been, I think it's being surfaced in March this year. So they're looking for contributors and sponsorship. And if you think this actually should be a project that should be maintained and propagate it forward in the community, please contribute. And just to end on a lighter note, I'm just going to showcase how can we control our cluster state by using Excel spreadsheets. And let's see. Cool. So currently, I'm just going to showcase all the pods I have in my cluster. And I've already connected with two Google spreadsheets, which means I'll be able to see all the namespaces available in the cluster, as well as any deployments we have with a desired and actual state of actual number of our pods. And to showcase how actually this works, let's go to, for example, Argo CD. And I'm going to say that I want 5 replicas of this particular application. It will watch for these changes, and we actually should see it in our cluster. We see 4 new pods for our application controller. Currently, it only supports the addition or deletion of replicas, so you can scale up or down, but that's the extent it goes. Again, if you think this is a project that needs to shine forward, now is the time to contribute. And just to conclude all the techniques we've been exploring today, we can see that the evolution from the CLI to GitOps had a lot of hops. We started from techniques or commands such as kubectl apply on a particular declarative file, towards moving to kubectl plugins, which allowed us to introduce actions such as kubectl microservice create. Again, we have a very powerful movement in the community towards improving and enriching the why and how can we showcase Kubernetes to engineers of all levels. But more importantly, we see that we have a powerful movement towards techniques to truly automate the deployment, such as techniques such as GitOps and even SheetOps, if you think about it. And this has been possible because Kubernetes uses a declarative configuration schema that really advocates for extensibility and optimization of the end user journey. However, the cluster interaction chronicles are far from completion, because you can think about what we've explored today, all of these mechanisms, as just the building blocks of the DX tomorrow. And this pretty much concludes all the key points I'd like to transfer to you today. We started by exploring the cluster CLI and how it supports the imperative and declarative approach, and transition towards the kubectl plugins and wrappers, which are translated in the multiple dashboards and UIs. But lastly, we had an overview of powerful mechanisms to manage your application, such as ClickOps, GitOps, and even SheetOps. If you'd like to find out more about today's topic, I am going to publish an article later on today with more details. You'll be able to spider through all of these resources. As well, I'm not sure if you have enough time, but I'll be available on social media to answer any questions you have in regards to today's talk. Enjoy the rest of the conference. Thank you.
Hey, so Katie, we actually have a few questions in chat. If you want to, if you're interested in taking them, I can read them out.
Yeah.
So the first one is, where does operators fit with Helm and Customize?
When do we talk about operators? Do we refer to customer source definitions? Or
I think just in the general state of the world, yeah.
So I think it really depends on what level of abstraction you actually want to have here. Because with Helm, in some of the previous examples and companies I've been working with, we really used Helm because it just allowed enough abstraction for our application. We didn't really need to create a different CRD to deploy our application. However, I do understand that there might be cases where you really want to have a fully managed state of your application for the cluster. So if it's going to be, for example, deleted, how do you bring back your application? How do you manage all of those, for which you require an actual controller for your operator, which is a more complex use case. However, I think it really depends on the use case. It really depends on the abstraction layer you want to introduce. But more importantly, with tools such as Helm and Customize, you already have a good enough abstraction layer. If that's enough, use that. No need to overcomplicate things. However, if it doesn't suit your use case, the operators are going to be the answer.
Cool. So we've got a few more coming in from the chat. Is GitOps a widely used pattern currently?
I think there is a shift towards that. I don't think, I think it's going back to the technical radar. Like if we put it into one of those verbs, I think it's currently in a lot of like trialing and assessment. I haven't seen companies who are using GitOps in production yet, but again, KubeCon in Europe was postponed, so there was no opportunity to network enough about this. But I can see a lot of, I see more and more steering the community to talk about it, to actually prototype things around GitOps. So I would say there is definitely a shift towards that direction.
Cool. So how do we create the sheet in the first place? We've got some exciting questions about SheetOps. How do we create the sheet in the first place, and who is applying the configuration at the cluster level? Is it Flux or Argo?
So with the SheetOps, what we actually need is an API token, because we can enable Google Spreadsheets to actually connect to the endpoints. We just need that, and we just need to connect to our spreadsheet ID. I think if I can share my screen very quickly, I could showcase that. Let's see. Can you see my screen?
Yep, you look good.
Cool. I'm just going to sign out, and let's see if I can. Cool. I'm going to delete the tokens so you can see it for now. I'm going to delete them after the talk. So as you can see, we just have a client ID, an API key, and then the spreadsheet ID itself. And with this, it's actually going to connect to the spreadsheet itself. And what I'm actually running here is a kubectl proxy to my cluster, which we're not able to see. And once I have that, my connection to the Google Spreadsheet is actually enabled straight away. So there is, it's pretty straightforward. It's just a way to talk to it. Yeah, I don't use any mechanism to deploy it. It's very early stages at the moment. But again, let's think about it as a good way to interact with the cluster. Why not?
And last one, what inspired SheetOps?
What inspired? The desire to go away from YAML. I don't know, that's their mission. That they actually quite, how can I say it, dedicated to that. I've heard a lot of complaints about YAML in the past. So again, this is something you'd like to dismiss in the future, contribute to this one. Let's replace YAML with Excel. Why not?
So I think those are all the questions we have in the Q&A section. Thank you so much, Katie, for taking the time today. So more people are asking about SheetOps. There will be links posted for SheetOps and the repo for contribution if you want to take a look later. Katie is available on social media. You want to give them the handle real quick?
It's going to be at K_Gamanji. If I'm not mistaken.
Right.
Yeah.
All right, thank you.
I'm going to post the slides and more details, so you'll find me, I'm pretty sure.
All right, thanks so much, Katie.